Alright, so we're going to be, what the heck? We're going to be taking a look at some of our proofs that we're going to be seeing with parallel lines. If you could work, computer, I'd appreciate it. Alright. Yeah, so proofs for this unit are going to be shorter than the ones we've seen before. They're going to be using the angle relationships that we've talked about already. We've set the foundation for what those angle relationships are. We're going to either be starting with the angles and proving the lines are parallel, or starting with lines being parallel and proving something about angles. Okay, so this is really where it's important. Like I was telling you guys about the converse versus not using the converse of those rules. That's what really applies here. You need to know which direction you're going in to know if you're using the converse of that idea or just using the original theorem or postulate. So for this one here, I know that angle 2 and angle 3 are congruent, and I'm trying to prove that A is parallel to B, right? This is actually proving the converse of the alternate interior angles theorem. Right? Our alternate interior angles theorem tells us that if the lines are parallel, then I know the alternate interior angles are congruent. We're trying to prove the reverse of that. Okay? So this is going to help us understand why it's true that we can use the converse. So first of all, how do you guys always start a proof? Given. Okay, so I know that angle 2 and 3 are equal based on the given. Okay? What else do I know? Angle 1. Angle 1,
Vertical angle 3.
which means that they're congruent. So you can say that angle 1 is equal to or congruent to angle 3. That's the best that my keyboard could do for angles.
No, vertical angles are congruent.
Vertical angles are congruent. Is the reason? Based on those two statements, what's something I could follow up with?
No, it doesn't.
Yes, it does. You can use these two steps, right? If 2 is equal to 3, listen guys. Hold on. If 2 is equal to 3 and 1 is equal to 3, then 2 is equal to 1. Alright, so remember, if two things are equal to the same thing, then they must be equal to each other. You guys remember what you could write for that? You can write transitive or substitution. I'll accept either. Well, we're about to use that. So we're actually saying that they're congruent based on the fact that we have the previous two steps, right? Because we're trying to prove that the lines are parallel, remember? So this is actually a really good point. At this point in the proof, we do not know if the lines are parallel or not. So remember, corresponding angles are only congruent if the lines were parallel to begin with. Okay? So that's why we're not going to reference congruent angles to say that they're congruent. Sorry, corresponding angles to say that they're congruent. Yes?
We already know that angle 2 and angle 3 are congruent, then why do we have to know that angle 1?
We're proving why that theorem postulate, or that theorem converse works. Guys, do you guys remember what a theorem is? It's something that you need to prove in order to know that it works. So we are currently proving why that converse works. Okay. Shh. Quiet, please. So now I'm here, right? Now you guys may have noticed this, I hope you guys did. The alternate interiors and the consecutive interiors rules are called theorems. What do you call the corresponding one? That's a postulate. A postulate is different from a theorem because we take a postulate to be true without needing to prove it. So you can use a postulate like a definition within a proof. So now that I know that angle 1 and angle 2 are congruent, how can I use that to then prove that the lines are parallel? That's the corresponding angles postulate converse. Because if you have the angles first being congruent, then you can conclude that the lines are parallel. So that's bringing back what Daniel was saying. We are going to use corresponding angles, but after the fact, not before. We're using them to prove that the lines are parallel.
So if angles 2 and 3 congruent, why can't you just jump to A is parallel to B using the what's called
Because it's a theorem, not a postulate. The postulates are like the definitions and rules that you're allowed to use. Now that we've proved this, I got Once you prove the theorem, then you can start using it a little bit later, but you don't want to use the theorem itself within the proof that you're using to prove the converse. Because the theorem you would need would be the converse of this, so you don't want to use circular converse. Alright. Does everybody see how we followed through that one? The ultimate goal was to prove that the lines were parallel, but you can't use the alternate interior angles because that's what we're trying to prove in the first place. That would be circular. You don't want to use alternate interior angles theorem to prove the converse of itself. You can't use something to prove itself, right? It's circular. So we had to adjust it to the corresponding instead so we can use a postulate to prove a point. Okay? Come on.
Look, it's stretching down there. Don't see.
I understand what it's doing. I just don't know how to fix it, so I'm doing my best. Alright, number 2. I have 2 givens provided, and it is wise to separate them. So I'm going to use my first given to say that A and B are parallel. If you would like to use a marker or highlight or something to highlight them. So you can see A, B, and EC are these horizontal ones right here. Okay? Based on the fact that those 2 are congruent, those 2 lines, what can I say? These 2 lines right here are parallel. What can I say? Yes?
Angle 1 is equals angle E because of alternate interior angles.
Angle 1 is what?
Equals angle.
No, it's not. Nope. Okay.
Angle 1 equals angle 2.
Okay, angle 1 equals angle 2. That's something you could say. What's something else? Okay, you could say angle 4 equals angle 5. So there's one more you could also say.
Angle 1 equals angle 3.
No, 1 and 3 are not on the same transversal. You could also say 8 equals 2. But of those options you guys just named out for me, which one would be most helpful in getting us here? Angle 1 equals angle 2. So when you guys have these proofs, you're going to have a lot of different angle relationships you could use. So that's why it's very important you guys look at the proof statement to make sure you're using the relationship that gets you closest to this. So it is true that 5 and 4 are congruent, 2 and 8 are congruent, 1 and 5 are supplementary, those are all valid, but they're not relevant. Right? Why would angle 1 be congruent to angle 2? What would your reason be? Or what would you? Corresponding angles postulate. This is not the converse, this is just the normal postulate because you're going from lines to angles. If you start with the lines being parallel and ending with the angles being congruent, that's the postulate, not the converse. Alright, how do I know that BC is parallel to EF? Guys? Given?
Yeah.
I'm using my second set of information. BC and EF are these ones right here that are slanted. So what are some things that I can conclude if I know that these 2 lines are parallel? Just name them off. Okay, 6 and 5 are congruent. 2 and 3 are congruent. Use a point, don't say that. Only use the numbered ones. 7 and 5 are congruent. We have a lot of different relationships. But what's the one that I want to use? 2 and 3. Because with this first relationship that brought 1 into the picture, now I'm using 3 into the picture. Right? So I'm going to use the relationship between 3 and 2. How do I know that 3 and 2 are congruent? The corresponding angles postulate. If lines are parallel, then corresponding angles are congruent. That's the statement of the postulate. Alright, I have everything I need to make my conclusion that 1 is equal to 3. How? How can I say that 1 is equal to 3? Substitution or transitive, whichever you would prefer. Because 1 is equal to 2 and 3 is equal to 2. If they're both equal to the same thing, they must be equal to each other. You guys will have lots of options for angle pair relationships to use. Guys, I'll wait until everybody's listening. When you have equal relationships in these proofs, you're going to have lots of options. That means you guys have to be very strategic about which ones you use. There are lots of valid relationships, but many of them are totally irrelevant. So be very careful when you're sorting through. Alright, here's an example of one from scratch. It's just like before, you'll have some that are fill in the blank, some that are from scratch. So how would I start this one? Okay, and that is given. Alright, what can I conclude based on the fact that those two segments are parallel? Sorry. Okay, I can conclude that 1 is equal to 4. Why? They're alternate interior angles, but how would you state that as a reason for proof? Alternate interior angles theorem. That one's a theorem. The theorem states that if you have parallel lines, then alternate interior angles are congruent. So we're just using that theorem as our basis. Is there anything else I can conclude based on the fact that those lines are parallel, or is that it? That's it. All right. So now what do I bring in next? Okay. Where did that come from? It was the second given. I had 2 of them. So now I'm going to bring that into the picture. If I now have that 1 is equal to 4 and 1 is equal to 2, what can I conclude from those two?
4 is equal to 2.
4 is equal to 2. Why?
Because it's
Transitive or substitution, whichever you guys want. Okay. Does everybody follow? All right. Now what? Angle 2 and angle 3 are congruent. Why? Vertical angles are congruent. Notice that I'm trying to get to 4 being congruent to 3. So how would I do that? If 2 is equal to 4 and 2 is equal to 3, if they're both equal to the same thing, they must be equal to each other. That is the substitution or transitive property. Alright? Those are examples of your generic parallel line proofs. Yes. I'm actually going to transition into triangles. We're going to see more triangle proofs in Unit 4, where you're trying to prove that triangles are congruent. Also interesting proof. But we're going to focus on 2 specific theorems today. We're actually going to learn how to solve using them, but we're going to prove why they're true first. So the triangle sum theorem, I'm sure you guys have already heard. All 3 angles in a triangle add 180, right? You've heard of that? All of the angles in a triangle add to 180? Yeah. That is a theorem called the triangle sum theorem, and we're going to prove why that's true using parallel lines. We're also going to learn about a theorem called the exterior angle theorem, and prove that one as well. And then we're going to use them to solve on the next page. Alright, so you're going to have a generic triangle right here, and then I'm just going to stick another line on top that's parallel to the bottom. So my given is that those 2 lines are parallel. So that's your first statement. I'm going to have one side of the triangle, typically the bottom, and then I'm going to draw an extra line on top that's parallel. I'm going to call them A and B. So A is parallel to B. Based on that, what's something you can conclude? Yes. 5 and 3 are congruent. I believe I put that on my 3rd line, but you can write that on your 2nd line if you'd like. Why would 3 and 5 be congruent? Alternate interior angles theorem. Remember, this is not the converse, this is just the regular theorem, because we're going from parallel to angles instead of the other way around. What's something else I can conclude?
1 and 4.
1 and 4. Why? Because of the alternate interior angle theorem. We have 2 different transversals, so 2 different sets of alternate interior angles. Can I do anything with those 2? So like substitution to merge them together?
You don't know that.
You don't know that they don't have anything in common. They don't have anything in common. So you can't use substitution the way that we have before. Don't think that always follows, right? They don't have anything in common, you can't do that. So think about something different. What do you notice about the proof?
1, 2, and 3.
Equal, we don't have anything about 180 yet. Maybe we'll have to bring that in. Say again?
4, 2, 5.
4, 2, 5? Yeah? Angle 4, angle 2, and angle 5 at 180. Once you guys are at a roadblock, always look back at the proof. Bring back into the proof what you need. Does anybody know why I can say that?
Supplementary substitution.
Supplementary is for 2 angles only.
Linear pair.
Linear pairs for 2 angles. Angle addition postulate. 4 plus 2 plus 5. Yes, they're straight angle. So I can say that because they add together to create a straight angle, using the angle addition postulate gives me that equation. Now what can I do? Now you can use substitution, right? What's 4 equal to?
1.
So can I swap it out? Right, 2 is equal to itself. What is 5 equal to?
3.
So I can swap out those angles to get it to look like our proved statement. And what property lets me do that?
Transitive or substitution.
Well, this one would definitely be substitution. We're not going to use transitive this time because it's just a straight substitution into an equation. Right? Everybody see how I did that one? Alright. Our second theorem we're going to talk about, called the exterior angle theorem, says that if you have an exterior angle, which is basically if you extend the line outside of the triangle, this outside angle is going to be equal to the 2 inside angles added together that are across. We're going to keep the outside angle of a triangle is equal to the addition of the 2 inside angles that are across.
So 1 and 3.
So 1 and 3. So angle 4 in this picture, angle 4 would be equal to 1 plus 3. Alright? We're going to prove why that's true. We're also going to use that to solve in some equations in the next page. So, how can I start? The given. So the given's a little bit strange looking. I'm just going to say I have a triangle with an extra ray attached to it. So I have triangle cat with the extension of AT. It's a ray, so it's continuing out. That's given. Alright. All that I know is I have a triangle, guys. What can I conclude? Yep. That's simply something we can conclude if we know we have a triangle. All the angles should add 180. That's triangle sum theorem. It's a new theorem you guys need to know. If you're using all of the angles inside of a triangle, it's called the triangle sum theorem. Alright, what else? Okay, so we know that 1 plus 2 plus 3 equals 180. Is there another relationship with angles in the picture?
4 plus 3 plus 2 plus
2 plus 4. What kind of angles are 2 and 4 when you look at them? They're a linear pair. So I know that 2 plus 4, angle 2 plus angle 4 is equal to 180 because they're linear pairs. So definition of linear pair. All right. Now, what do you think is going to happen?
Well, you have to wait a bit there.
Angle 4 equals
You do. Good point, Keely.
4 equals angle 3.
Hold on, no, there's too many ideas. Wait, stop. Raise your hand if you have an idea, and I can confirm whether it is correct or not. Haley.
You substitute the 1 angle 2 and angle 3 and put 180.
Into which equation?
The angle 2 plus angle 3.
So, you mean take this right here and put it there? Yes.
Yeah.
They're both equal. This is a substitution property. They're both equal to the same thing, so they should be equal to each other. If both of these equations are equal to 180, I can set them equal to each other. Substitution. Does everybody see how I was able to get this conclusion from these two steps?
Yes.
Now how can I go from here to that? I can subtract the 2. Alright? So everybody listen real quick. We are going to be using this extensively, not only in this unit, but in others to solve. So I'm introducing it now, but we'll see it again in just a second. If you guys see an exterior angle, you need to remember that if I ask you how, or what the measure is, you go across the triangle to these two and you add them together. So if like this one was 70 and this one was 30, and I ask you what's the measure of angle 4, you'd say it's 100 because 70 plus 30 is 100, so that means that angle 4 is 100, okay? So make sure you keep that in mind when we're on the next page. Before we get there, we're going to introduce a corollary. We have all sorts of different words now. We have postulate, we have theorem, now we have corollary. Corollary.
Corollary.
Corollary.
Corollary.
Alright. A corollary is still a theorem. It just has a new name. No, it's not a new theorem. It's a theorem that follows from a theorem. So like some brilliant person was like, oh, that's a theorem, that's cool. Here's another theorem that's very, very closely related to that is based on this theorem. That's called a corollary. It's not fake, it's just, it follows. It's a new idea that was inspired by a theorem. Okay? So we're going to do this right here. This is called the corollary to the triangle sum theorem. It states that the acute angles of a right triangle must be complementary. In other words, the acute angles, because in a right triangle you have one right angle and 2 acute angles, they're saying that these two have to add up to 90. That makes sense, right? If you already have a 90, the other two have to be 90 to get to your full 180. So we're going to prove that. I'm going to start with the given. I'm going to start with the given. I have a triangle, and I know that angle I is a right angle. Given. Alright. What can I conclude based on just that? Yes.
Measure angle I is 90.
Yes. I know that angle 1 is 90 degrees.
Is that a what?
It's an I. Well, in whatever font that Smartboard uses, that's what a capital I is.
That's a silly
Then you write it that way. Yeah, write it that way. Alright. Why? Definition of right angle. I was told I had a right angle. I know what that means. It means it's 90 because it's a right angle. Alright, what else can I conclude? So that's all I can get from the given. I need to now look more at my picture and understand what's going on there to add more. Dante? Okay. I have a triangle, and we just learned that whenever you have a triangle, you know all 3 angles are going to add to 180. So I can use that fact. That's the triangle sum theorem. Can you guys see where we're going? You guys see where we're going with this?
Yes.
What happens next? Substitute what? Substitute a 90 for I. Okay. And then what? And then subtract. Oh, I'm sorry, that's a typo. That should say 90. That right there, that's an error. Because I copy pasted and didn't fix it. Angle F plus angle G should equal 90.
No! You're learning about these now?
Yeah. I didn't want to.
Yes, you did.
I didn't want to. I was actually going to put it in a different unit. Why not? My teammate said that we needed to teach it this unit.
No, you
I argued my point.
I can't believe I don't say it. Like, this is what I did and you're wrong.
I can't. We have to agree. Yes. All right, quiet, please.
That's what I equilaterals.
I get in trouble if I do that.
Yeah, I do.
All right, guys, listen, please. I hate how much I have to shout when I teach you guys. It's so annoying. I don't have to shout for any of my other classes. It's just you guys. I would appreciate it if you guys would be quiet. Is everybody okay with the proofs? We'll practice more. I know, I'm sorry, I made a typo.
Oh, okay.
I made a typo. I was copy pasting. What was I saying? Oh, is everybody okay? We're gonna see proofs more. We're gonna practice them more. Right? But is everybody okay for now? Okay. All right. More quickly, we're just gonna introduce. You guys know this stuff, right? Practice triangles. We're gonna practice some basic solving questions using the triangle sum theorem and the exterior angle theorem. You guys know an equilateral triangle, right?
Yeah.
All the sides are the same. Isosceles.
That one.
Two sides are the same, right? A little bit of vocabulary you guys need to be aware of. This angle right here that's in between the two, no, it's not always 90. The angle in between the two sides that are congruent is called the vertex angle. The other two are called base angles.
Oh, because they're on the ground.
Yeah, well, they don't have to be. You can have an isosceles triangle that's turned around. Yeah, so they're not called base angles because they're on the bottom. They set the foundation for your triangle because they are the bottom of the two. Yeah, so that may say the base angles are congruent. You need to know which ones are the base angles. All right, scalene. Everybody knows. No sides are the same. Equiangular. Have you guys ever heard of equiangular? Equiangular. Mean that all the angles are congruent. Or does that mean that they always have to be 60 then?
Yes.
Why? They should add up to 180?
Oh.
Sure.
Wait. So it's basically just an equilateral triangle.
Yes.
It's basically just an equilateral triangle with angles.
Yes. So equilateral are always also equiangular. They're equivalent. Acute, right? Acute angle means that, acute triangle means that all the angles are acute. So I did this on purpose. Listen. I did this on purpose and left one blank. Sometimes they'll do that. They'll give you a triangle that has two angles in it and ask you what kind of triangle it is. Can you tell what type just by looking at it like this?
Yeah. No.
You have to find out what this is
Gotta be
first.
like 70 plus 40, and then that minus 180. And then if it's 90, it's big.
Yeah.
It's not.
So if you do that, can anybody tell me what this angle would be? So go ahead and write that into the picture, guys.
70.
The 110 equals
7.
Oh.
So now it's acute, because all three are acute. Right. Stop. Alright. For the obtuse triangle, how many angles must be obtuse?
One.
Just one. Can you have more than one obtuse angle in a triangle?
No, because that would be too big.
Yeah. You can't have two obtuse angles connect. Right? Remember, obtuse angles are greater than 90, right? But shouldn't all the angles in a triangle add to 180? So if you have two angles that are more than 90, that's going to be more than 180. So it's impossible for a triangle.
Oh, yeah.
Unless you're in non-Euclidean geometry, which we're not going to learn. And then a right triangle, you guys know hypotenuse, right?
Yeah.
Okay, so you have your two legs, your hypotenuse.
Is it like the creator of Euclid.
Hypotenuse. I heard someone ask. Hypotenuse is whatever side of the right triangle is across from the right angle.
Wrong side.
Alright. Here's the theorem we already learned. Right, in a triangle, the interior angle is at 180. Exterior angle, we also learned that one. The measure of an exterior angle is equal to the sum of the two opposite interior angles. So like an angle 1 is equal to 2 plus 3 in this picture. This is another one you guys also need to remember. That's supposed to be a star. Alright. This is called the isosceles base angle theorem, right? If two sides of a triangle, or sorry, this is biconditional. Two sides of a triangle are congruent if and only if the angles are also congruent. So if you guys have an isosceles triangle, if the two sides are congruent, that means that these two angles are congruent and vice versa. So that's something that we're going to be seeing when we're solving. If you notice you have two congruent sides, then the two angles that are attached to those sides are congruent. Or if you have two congruent angles, then the two sides that they're attached to are also congruent. So we're going to be using that to help us solve. So you could, I'm sorry? It's the base angles. So it'd be those and those if you want to add to the picture. All right, we're going to use those three ideas to help us solve these questions. All right. So take a look at the first one. This one right here. What kind of triangle is it? It is obtuse.
Wow.
It's also isosceles. All right. I need to know how to solve for x in this triangle. You guys know we just talked about a special theorem that has to do with isosceles triangles specifically. Ready? Yes. Okay. Okay, so hold that thought. The isosceles base angles theorem tells you that the base angles should be congruent if the two sides are. But the question is, which ones are the base angles? The base angles are whatever angles are touching these sides. So if you have this side, you want to use that angle and that angle. If they're congruent, you can add that in. If they're congruent, you can add that mark into the picture. And then what other theorem can I use to help me solve for x? I just have a bunch of the triangle sum theorem. You know that this angle plus this angle plus this angle equals 180. So 4x plus 6 plus 110 equals 180. Do a little bit of math there. Do you end up with 16?
Yep.
Yes, you do. Right? So I had two theorems in it, the isosceles theorem and the triangle sum theorem. How do I solve for x in this next one? Yeah, just add them all together. So that equals 180. 3x plus x plus 2x. And then 40 minus 5 minus 17. Is that 18? So I just combine like terms. If you add all those together, I just combine like terms there. You said it equals 180. Yep. You can write it out if you want to all the way. I just combine my terms to begin with. All right, here comes the interesting one. Over on the right side. What kind of situation do I have? What would I call this angle right here? Exterior. So I'm using the exterior angle theorem to help me, which states what? This angle should be equal to the two angles across, the two remote or opposite angles added together. 6x minus 7 equals 103 minus x plus 2x. That's the exterior angle theorem. Everybody understand how I wrote that equation? Okay. You solve it. Let's see. That would be
22.
Or wait. Nope. Just kidding. I made a mistake. I can just make it noise. That would be a 5, right? Because it's hard to get. Okay. Excuse me. X equals 22. Right?
two exterior angles.
Yes, 2 exterior angles this time. Ideas.
I don't know.
Oh my god.
That's what I said.
Ideas?
Linear pair.
Huh?
Linear pair.
For what?
For 140.
To
I
where?
got it. Wait.
The other place.
Here?
Yeah.
Here?
No,
No,
it's
no,
the inside.
Here?
That inside.
Okay. How is that helpful?
Because
Wait.
now we know
Now you
the
have
inside.
two of the angles.
Wait, what if I said
And you know that x would equal those two.
Linear pair.
Oh, it's a linear.
Linear pair.
Oh, and then you have to use the exterior.
Yep. Do I have enough for the exterior angle theorem?
Yeah.
Yep. It's just x equals 40 plus 85.
125.
85.
125.
Yes. Is there another way you could have done that?
Yes.
There's a longer way you could also do it, but it's not as direct. You can find the third angle by doing, like, all these should add up to 180, so you can find the third angle and then do linear pair. That's another way you can do it.
And you also vertical into 145.
140 plus, no, those are not a linear pair.
Silly.
No, because you're like, you take the vertical 140 and you consecutive x.
No, because they're not parallel. Don't try to use parallel lines when they're not parallel. Alright. Some of these are super boring. Let's just talk about how to do them, but not do them. How would you do this one?
You got it on the side. No.
It's isosceles. You're gonna see how these two angles are congruent?
Yeah.
So these two have to be congruent?
Yeah.
You just set them equal to each other? Boring. Alright, what about this one?
They're equal.
It's equilaterals, you just pick two, set them equal to each other. Boring. Okay. This one's cool though.
No, no.
This one's
It's
cool.
four.
No, it's actually very important on the
No.
test, okay?
Just call it four.
Whoa.
This kind of question's on the test. That's why we're talking about it in this unit instead of the one that's next, which is what I wanted to do. So, I need you guys to draw a picture for me.
No.
The measure. I know you guys are secretly wonderful artists, and I want to see that. So, the measure of an exterior angle.
I got
Oh, I can do this.
So, draw a nice little triangle with an exterior angle.
Broken triangle.
okay.
I know that the exterior angle is 125.
Oh, yeah.
So I have a lovely little triangle here. And then it says its remote interior angle. Remote is another word for opposite. So that means we're talking about these two angles right here. Okay? They are in the ratio of 2 to 3. And I'm trying to find what their measures are.
Oh my god.
You guys know how to put that into the picture? As a ratio, it's 2 to 3, but do you know how to put that into the picture? No. No. Yes. One of them is 2x, the other one is 3x. As a relationship, they are 2 to 3. That's the ratio. But isn't 4 to 6 essentially the same ratio as 2 to 3? It's not simplified.
Yeah.
What about 10 to 15?
Yeah.
Also, yeah? So the reason why we're writing them as 2x and 3x is because we don't know which particular relationship it is, whether it's simplified or not. So I use the x to represent it could be a multiple of those two numbers. Doesn't have to be exactly 2. Are you going to have angle measures that are 2 and 3?
Yeah.
No. But they have to be multiples of 2 and 3. Right? So now, what's my equation going to be?
5.
Okay. I'm going to use the exterior angle theorem. I'm going to take the two angles, add them together, set equal to 125. If I remember correctly, it's 25? Yep. Okay. But is the question asking for x?
No.
It's asking for the angle measures exactly.
75.
We're already with them. Yes.
20.
So one of them would be 75. The other one would be 50. Now, how would I check to see if I did this correctly? Okay, you need to add them, make sure they add to 55, which they do. But then how do I make sure I have the ratio part right? So you can have a lot of different angles that add to 125.
55 by 50.
Okay, everybody take your calculator or think about it. What's 50 divided by 75? 0.6 repeating, and if you turn that to a fraction, what do you get? 2/3. So it's the same ratio, just not simplified. There is a question like that on the test. So you guys need to know that when you see something as a ratio, you just attach an X to each of those numbers and stick it in the diagram. Okay?
Are the rest 40?
Well, actually, no. These two are very interesting, so we're going to do that. We'll finish with these two. They're the cool. All right. What's X? You shouldn't even have to think. What's X? 60.
Oh,
That's me one.
This is an equilateral triangle, which means it's also equiangular. So each angle is 60. How would I find Y? Okay, so I know that we have a 60 in all of these different positions. I have to add it into the picture. So we know this is a linear pair. There's no information in this triangle, so I gotta add some. So this would be 120. You may have to use one triangle to find information in the other. So make sure you're using all of your resources. Now what? Okay, what does that give me? What kind of triangle is this one on the right? Is it isosceles? If the two sides are congruent, then the two base angles are congruent. So if this is Y, what's this one? You guys see what to do now? Yep. Once you have all three of the angles marked with something, whether it's a variable or a number, you know that they're going to act 180. So 2y plus 120 equals 180 and you solve. 230?
Why does it this next one?
Yes. Alright. Alright, let's finish with this last one. Which variable do I have to find first? Yes. I have to find y first. How? And this triangle, they should all add to 180. So add those two and subtract to find what's missing. That'd be one.
Daniel, get the door.
What is it?
119.
No, I said 3. Okay. What now?
Linear pair.
Linear pair. So x is equal to?
61.
Alright. And then z?
47.
You would use the 61 you just found, the 72, use the triangle sum theorem. So there's a very, very small part of the test that has stuff related to this. Knowing the exterior angle and triangle sum theorems are going to be really helpful for you. As well as this guy right here. You might want to put a star to remind yourself to review that type, because there is a ratios question on the test. So make sure you know how to do that. Draw the picture, write the equation, etc., etc. All right, we have about 15 minutes-ish. So I'm going to have you guys work on the graded assignment now. And while you're doing that, I am going to pass out the tests from Unit 2. So I'm going to take a quick glance while you're working on the graded assignment, and then once you're done, I'm going to take them back. Okay? 1 second.
Oh, no, I already know my story.
What's your answer? Maybe.